Good day to all of you. Today we shall study BFS and DFS, that is breadth first search and depth first search. This is part 2 video. In part 1 I have covered how to write BFS sequence for the given graph, and in this video, which is part 2, I am going to cover how to write DFS sequence for the given graph. Our sincere thanks and acknowledgement to authors Ellis Horowitz, Sarta Sani and Susan Anderson Fried, authors of the textbook Fundamentals of Data Structures in C. The content of discussion I have taken from this textbook. To recall what is a graph, it's a non-linear data structure. It has vertices and edges. A graph can be written as G of V and E, means it is a set of vertices and edges. The vertices are also known as nodes and the edges are also called as lines or arcs. They connect any two nodes in the graph. What are some of the sample graphs and their representations? Then where BFS and DFS techniques are used, I have covered in my previous video. Now directly going to depth first search. In DFS for a graph, we traverse all adjacent vertices one by one. When we traverse an adjacent vertex, we completely finish the traverse of all vertices reachable through that adjacent vertex. This is same as tree traversal, where we first completely traverse left subtree and then move to right subtree. The difference between trees and graphs is trees will not have cycles, but graphs may contain cycles. Now we shall learn how to write depth first search traversal sequence for the given graph. The sequence is written as final answer is visited array. So the size of visited array is 7 because there are 7 vertices in the given graph. So in BFS we had taken queue data structure. Here we take stack data structure. So queue data structure is first in first out data structure. This stack data structure is last in first out data structure. That is, if we have put A, that is pushed onto stack A, then B, which was pushed last, that is B, that is popped out of stack first, then A. So which was pushed onto stack last, that will be taken out or popped out first. That is what is stack data structure. Now let us learn how to write DFS sequence as visited nodes array here for the given graph. So let us start from node A. So A is added to visited node array. Its children are B and C. B and C are pushed onto stack. C and B in that order also we can push. Hence this problem has multiple solutions. So which was pushed last here? C, that is popped out. When it is popped out, it is added to visited node array and it is taken out of stack. So now from A to C. So A to C we have moved. We'll have to consider C now. Which are its child nodes or neighboring nodes F and G? They are pushed onto stack. Which was pushed last? G, that is popped out. When it is popped out, it is added to visited node array and it is removed from stack. Now C to G we move. So C to G. Which are the children of G? It doesn't have any children. So we'll have to backtrack. Means we'll have to go back from G to C. C is parent of G. It is already covered. Because it is already covered, next F is popped out of stack. When it is popped out, it is added to visited nodes array and it is removed from stack, and from G to F we move. Means F is considered now. F doesn't have any children. That is why we'll have to backtrack to its parent C. C is already covered. Hence we pop out B. When B is popped out, it is added to visited node array, and this is removed from stack. Now F to B we move. Now we have to consider B. Its child node or neighboring nodes are D and E. They are put onto stack. So which was pushed onto stack last? E. That is popped out. When it is popped out, it is added to visited node array, and that is deleted from stack. Now we move from B to E. B to E means E we have to consider. Since it doesn't have any children, we'll have to backtrack. So we'll go back to B, which is its parent. So we'll have to pop D from stack. When it is popped out of stack, we'll add it to visited node array, and we remove this one from stack. Now we move from E to D, that is we have to consider D node. It doesn't have any children. We'll have to backtrack to B. So B is already covered. Again, that completes the procedure. This is the DFS sequence for the given graph. Okay. This is one solution. Here you can observe 7 vertices are there: A, C, G, F, B, E, D. And any vertex or node if you take, it is visited only once. And this is the DFS sequence for the given graph. I hope you understood. Thank you.